Thank you all for taking the time to attend today's meeting on getting started with R and an introduction to RStudio for data mapping. So again, welcome, whether you're an R novice or R expert, regardless of gender or experience, this group is for you. So every meeting I like to reiterate the mission of Our Ladies Global and consequently the mission of Our Ladies Irvine. It's an organization that promotes gender diversity in our community via meetups and mentorship in a friendly and safe environment. This means that there's no such thing as a stupid question. Please feel free to ask whatever you'd like of the presenters today or of each other. And we're all here to support each other and to help each other learn and grow in our careers. So I'd also like to take a moment to thank our sponsors. Our global sponsors are the R Consortium, RStudio, R Forwards, and NASA and the Datanauts program. And our local sponsors and friends include the Microsoft Developer Advocates, Edwards Life Sciences, OC Rug, the UCI Data Science Initiative, UCI Athena Breast Health Network, and our new sponsor is O'Reilly Media, which will be helping us via some revenue sharing. They're also offering us exclusive content in the form of ebooks, webinars, videos, reports, anything that you can think of affiliated with O'Reilly. Yeah, they're offering it to us and some other meetups around the world. So yeah, I'm grateful that we were selected for that program. Okay, so moving into first announcement, we have a new website, and if you have any new news related to R, any accomplishments that you're proud of, building a package or like presenting at a webinar or like a virtual conference or like writing a paper or something like that. It doesn't even have to be like anything that big. We'd love if you could write about it for our Ladies Irvine blog so that we can showcase the accomplishments of everyone in our community. Yeah, really that blog is there to showcase the accomplishments of anyone affiliated with Our Ladies Irvine in any sort of membership capacity. So yeah, if you have any ideas related to R or accomplishments related to R, we'd love to hear from you. And our email address is in this slide deck too, and also right there, irvine@ourladies.org. Okay, so our next meeting is going to be in July. We meet every other month on the third Tuesday of the month. And then we're going to be learning about R and Alteryx and also have a career speaker. It's going to be online via Zoom, just like this one. And it's going to be Tuesday, July 1st at the same time as this one from 6:30 to 8:30 p.m. Okay. Another thing we like to do every meeting is to highlight a notable woman in STEM. This time we've decided to honor Dr. Katie Bauman. Some of you may have heard of her from like all the news last year about how her team discovered the first picture of a black hole. She's inspirational in particular to this group due to her pioneering research in computer programming, signal processing, computer vision, and machine learning, fields that a lot of us are very interested in or have been a part of, whether in research or like taking academic courses. And yeah, I actually got to hear her talk about her research live last Saturday at the Caltech seminar. This year was the Caltech online seminar day, and gosh, her like enthusiasm for her research is infectious, and it's amazing. Just amazing when you hear her talk about it live. I'd recommend watching a TED Talk that she did at MIT, I believe, about her research, and it's just fascinating. So yeah, moving into our first presentation, getting started with R. Madeline Bauer, PhD, she wrote this talk, but unfortunately late this afternoon, she came down with a stomach bug, so I will be presenting this presentation in her stead. So here it is. Getting started, oh, hold on. Oh my goodness. Okay, getting started with R, a checklist. Okay, so throughout this presentation, she goes through where to get help through rseek.org and through other places, how to get or install R in RStudio, some R-Lays Irvine tutorials that describe these concepts and more, packages and browse vignettes, RStudio resources, and even additional resources. So without further ado, the main two sources that we'd recommend you to get help if you're just getting started with R, like complete novice, are rseek.org and our R-Lays Irvine presentations that we've written specifically for this community, Introduction to R and Getting Started with RStudio. So rseek.org is basically like a Google for R. When I was first learning R, I found it difficult to try to Google something and then put the R next to it. But then I discovered like Google something with R stats next to it, but still like the SEO is kind of off, you know, since it's such a short word and it kind of like fits in with other things, you know. So rseek.org is like Google for R, where it takes the sources stackoverflow.com, rpubs.com, which is like the RStudio, our Markdown publishing platform, CRAN, RStudio, cheat sheets, rbloggers.com, and other famous R sources, and puts them together like a search engine specifically tailored to R. It has all of these different tabs for you to tailor your search further. Like if you just wanted to look at CRAN stuff, you'd look at our project, GitHub, look at GitHub, etc. All of our R-Lays Irvine presentations can be found at this link. I also alluded to that by pasting the github.com/rladies-irvine in the chat earlier. Yeah, I wrote a tutorial that was presented a couple years ago about an introduction to R, how to download and install R in RStudio, update R in RStudio. I explain all of these with pictures so that it's a more complete picture of what's going on rather than just being like, once this message is here, then you'll, yeah. No, it's more intuitive when documentation has pictures always. I also go into how to update packages, an introduction to different data types, functions, different basic operations, an introduction to dplyr, which is basic manipulation of data, and helpful packages to get started with. So this is linked later in this presentation or in the handout that she gave. Also, she recommends Ryan Benz's tutorial, which was given at the same meeting a couple of years ago. He talks more about RStudio setup than like R setup and R packages. He talks about what you need to do in RStudio to set you up for success in terms of reproducible workflows. Yeah, how to get your environment working, what the different panes mean and how you can rearrange them. Yeah. He also went into how to set up your projects and how to set up the working directory. Yeah, via using RStudio projects instead of going like set working directory in front of every script. He also goes into RStudio IDE themes. Those are pretty fun. There's dark themes, light themes, even some like neon 80s themes. Yeah, and then some helpful keyboard shortcuts. Those can be extremely helpful. There is one that he showed that it's written in the tutorial where you can have multiple curses going on throughout the script, where you can do the same thing in parallel throughout the script. So that was pretty impressive. Yeah. More help, there's a lot of package documentation on CRAN, there's RStudio resources, plenty of webinars, plenty of cheat sheets, and they always explain things in a top-notch way with the most help that they can give. There's also this organization called R Coding Club. Yeah, I, to be honest, don't know much about them, but she knows a lot more about them. Okay, And then she writes here that how to find the perfect R package, use task views on CRAN. And then even more package info can be found in RStudio using the browse vignettes command. It opens a browser window with more detailed info about the package, both inputs and outputs, the type of data types that it accepts, what exactly the package and the functions do, everything that you would want to know about a package and the functions inside. Going back to RStudio resources, along with the webinars and cheat sheets, there's a free book online called R for Data Science. It's located at this link. It's extremely helpful for starting an R. I'd recommend it as like the first resource you'd look at. Honestly, it takes you from the very beginning, from installing R to loading a data set, to working with it, to building visualizations, building reports. Yeah, everything that you would need to know to get like an entry-level data analyst or data scientist job is in that book. There's also an online community. I'm not sure if she's included this link in this presentation or not, but there's an online community that goes with R for Data Science called the R for Data Science Online Learning Community. And it was started by Jesse Mostapak, who now is a developer advocate at Kaggle. And yeah, it's just a very welcoming community. And the mentors in that community are like veterans in the art industry, or in the art community. And they're all very kind people. They're all very helpful. Yeah, I'd recommend, along with searching for R for Data Science, searching for R for Data Science Online Learning Community, and their URL is very similar to this URL. And I can send it out along with this presentation later too. Okay, so this is more on our coding club. They have tutorials on Intro to R and other helpful links. And this is what their webpage looks like. I think that's the last slide. Okay, that's the last slide. So she also, along with this presentation, gave us a helpful handout that that aggregates all of the links that she placed in her presentation here in a more easily accessible format. So yes, she recommends starting here with rseek.org and then moving into our Arley's Irvine presentations. This is my intro to R presentation. This is Ryan Benz's introduction to RStudio presentation. How to find the perfect R package can be found here on CRAN. The command for getting package information in RStudio here. And then some additional information from RStudio here. And then some additional tutorials for like getting around the oh so common errors in R here. So yeah, all of these are on our GitHub right now. Yeah, everything that has to do with our meeting is on our GitHub right now and will be sent out after the meeting. So yeah, if anyone has any questions about this presentation, please enter them in the chat and I'll be happy to answer them.
Hi, Elisa.
Hi, Lily.
How you doing?
Good, how are you?
Good. John Lau, she has a question about that she is not able to open some resources from the HTML 2020 data mapping. So maybe we can do that at the end.
Yeah, so she was having trouble opening the HTML 2020 data mapping.
Yes.
Okay, here, let me show you how to do that. So Here, let me go to our GitHub. Okay, so yeah, this is the only HTML file here. So intro data mapping. Okay, so in order to download and view an HTML file on GitHub, it's kind of unintuitive that it doesn't display on GitHub because it's an HTML, but I digress. Anyway, so in order to view an HTML file from GitHub, you need to download it. Okay. My internet connection is, okay, there we go. And then it'll show you the raw HTML code, but, and it may look intimidating at first in this form, but in order to view it as like a regular web page, you need to right click, save page as, and then save it to like your desktop or something, or some easily available directory. And like save it as .html, and then in the all files type. Does that make sense? Because if you save it as a text file, then it won't be able to translate into an HTML file, depending on your computer, but most likely. Some computers automatically change it to HTML if it's a text file, if they can sense it, but if your computer is an older computer, you probably will have to change it to .html and then save as type all files, and then save. And then you should be able to open it in your browser like so. And if that doesn't work, please let me know.
Okay, thank you.
Okay, no problem. Any other questions before we take a quick 10-minute break?
I don't have more questions in the chat, but I don't know if somebody else wants to add additional things.
Okay. Okay, so seeing as I don't see any other questions in the chat, I'm going to start a 10-minute break right now, and then we'll come back at 7:24 to listen to Michelle Burns give an introduction to RStudio for data mapping. Okay, looking forward to seeing you all back in 10 minutes. Alrighty, everyone. Welcome back. And I'd like to introduce Michelle Burns and her presentation, Introduction to RStudio for Data Mapping. Thank you.
Thanks, Alyssa. Okay, so before I begin, I just want to highlight again that all this can be found on the Our Lady's GitHub repo. And just to kind of orient you, I actually did this presentation in R, and it was my first presentation using R IO slides. So if anyone has any tips or tricks for that, please feel free to drop some helpful links in the chat or something. But you can follow along by downloading the .rmd file and opening that in your RStudio. Or like Alyssa mentioned earlier, you can download the HTML file and it'll show a presentation like this. And just to kind of get you oriented with what it looks like in R, if you do that RMD file, the code is going to be in this gray blockage here. So that would be the part that you would run to follow along with the presentation. All right. So welcome, thanks everyone for coming. This is going to be an introduction in RStudio for data mapping. And a little bit about myself. I studied fish movements for about 3 years during my master's. And so a lot of my examples, or all of my examples really, are going to deal with fish movement data. But I think that a lot of these data mapping practices can actually be applied to a lot of different types of geospatial data. So packages used in this presentation include RGDAL, Fields, Geosphere, Tidyverse, and Maps. And I'll give you guys a second now if you want to write those down or download them. They might take a second to download though. And then I have some examples, I guess, of what I use them for also. Cool. So let's begin with the very basics, which is what is geospatial data? It's basically any data that contains geographic coordinates or GPS points. And it can be in a wide variety of different formats, including things like tables and shapefiles and even some photographs. And you're probably thinking right now, I don't know if you have much experience in geospatial data, but if you don't, you're probably thinking, what the heck even is a shapefile? And we'll get into that in a second. But for example, we have an example here to look at maps, and you can see the most recent earthquake data. So here we have the frequency of damaging earthquakes around the US, and anything that you can see on a map is essentially geospatial data. But geospatial data can actually be pretty tricky. And locations are usually given by two distinct numbers in latitude and longitude. But even kind of visualizing latitude and longitude and translating them into something that you can just remember is kind of difficult. Because even though this shows latitude lines as horizontal, in mapping and graphing, longitude is the value that's actually on the x-axis, even though it looks like it's up and down here. So one way to kind of get that trick in your mind a little better is if you look at this latitude figure and you move your cursor, I guess, along the latitude line, your longitude is actually changing. So your longitude is your x-axis changes, but your y-axis stays the same. Whereas if you look at the longitude, and you stay on one line of longitude, your latitude or your y-axis is moving, but your longitude or your x-axis is staying the same. So it looks counterintuitive, and that's just one of the very beginning things of what can make geospatial data pretty tricky. And to make things even more complicated, to designate direction, sometimes people use positive or negative numbers. So you would use a positive latitude if you're up here, negative latitude if you're down here. But sometimes people just use all positive numbers and just designate north or south or east or west. And even with that, you can get differences in what the decimals or the numbers actually look like. So you can have things like decimal degrees, which basically just look like really big numbers with decimal points at the end. You can have degrees, minutes, seconds, which what? So to kind of fix that for you guys in your head, there are 60 minutes in a degree and 60 seconds in a minute. So kind of like how you tell time, but it requires some mathematical translation to kind of get that into the same format as decimal degrees. There's also degrees, minutes, not minutes, and sometimes even meters. So in essence, geospatial data can be tricky and it can be pretty sticky. But once you get used to it and once you kind of know what format your data are in, and you have a little better handle on how to translate between those data types or those format types, it can actually be really satisfying. So geospatial data can be used to answer a wide variety of questions. Because my background is mostly on fish and tracking the movements of animals, today we're focusing on tracking animals and answering questions like where do they go and how do they interact with the environment. But you can also use geospatial data to answer a wide variety of different questions that may be more applicable to what you're interested in. For example, you can track flight patterns and answer questions like, can an airline add more flights to their schedule without putting too many planes on the same route at the same time? And you can even predict when the next earthquake might happen based on previous earthquake locations. And that's only a few examples of what you can do with geospatial data. So today, I want you to imagine that you are a marine biologist like myself, and you want to study fish movement patterns. So these are your 3 fish species. This is a horny-head turbot here. This is a vermilion rockfish here. And this is called an English sole. So they all have pretty silly names. And they all spend time at the bottom of the ocean. So they hang out in the sand, they eat creatures in the sand. And these 2 on the end are actually flatfish. So they kind of lie down like pancakes on the sand. So they're pretty cool. But you want to be able to answer some research questions based on these fish. So you want to know, are these fish spending time near a wastewater outfall? And this is because wastewater outfalls take water that's discharged from your toilet. So you flush your toilet, your water goes to a wastewater filtration, essentially, area. They treat the wastewater and they recycle what they can, but what they can't recycle goes out into the ocean through a big 9-foot tall discharge pipe. So you want to know if these fish are hanging out near that discharge pipe. And you want to know how close they are. So, and this could lead to a lot of different implications, because if these fish are hanging out near that wastewater outfall pipe, they could be exposed to harmful contaminants that might be discharged by that outfall. Because even though a lot of contaminants are taken out of that water, some kind of get through the filters because they don't have to be regulated yet, or because they have such low concentrations. But if a fish is hanging out near the outfall for a long duration of time, it could be accumulating bad contaminants, which could affect its health and the health of the entire population. In addition, some people actually eat vermilion rockfish, the fish in the middle. So if this fish is hanging out by the outfall pipe a lot and accumulating those contaminants, that could be bad for humans who eat that fish, because they might also be exposed. So here's your study site. It's the wastewater outfall that's about 5 miles offshore of Huntington Beach. And you're really excited to start your research. And so I'm going to go over first a little bit about the technology that you're going to use to answer these questions. So you're using something called acoustic telemetry. The basic way that this works is fish are tagged with these little transmitters here, and they go on or inside the fish. And these transmitters send out an ultrasonic signal. So that's a sound that you can't hear and that the fish can't hear. But what can hear is this acoustic receiver over here. And this acoustic receiver is always listening for tagged individuals in the area. And when that tagged fish goes by your receiver, it records the date, time, the location of the receiver itself, and the tag ID of that fish that was near you. And the cool thing is that if you get a lot of these acoustic receivers together in a grid system, if 3 or more receivers hear the same fish at the same time, you can actually get a GPS location for the individual fish instead of just the receiver. So you can basically track this one fish and many fish, however many you're hearing, through space and time at a pretty fine interval with about 5 meters of positional accuracy. So that's pretty cool. Okay, so now that you have a rundown of the tools that you're using, in your toolbox, you're given a shapefile with wastewater outfall location. So that's where that outfall pipe is. You're given a shapefile with water depths or bathymetry. A shapefile for the US states. That's just kind of for aesthetic purposes. And then you have your tagged fish locations. But before I get into this, we're gonna back up and understand what a shapefile is. So a shapefile is a set of geospatial files with a bunch of different endings, and they basically can map themselves. But the trick is that all of these files actually have to stay together to work. If you take one file out from the other group, they'll break. But when you're working in R, you only have to open the .shp file. Okay, So now we're going to start with some code. To load in shapefiles, you can use the rgdal package. So you can go ahead and open that package in your R. And you're going to load in each of these shapefiles using the read ogr command. So it's pretty easy. You just set the URL to where your shapefiles are, and you should be able to read them into your R pretty easily. And all of these shapefiles should be in the GitHub repo as well. So now we have to check our coordinate systems. So this is when I was talking about decimal degrees or decimals, minutes, seconds, or meters, all those fun things. And the trick is that you want all of these shapefiles to have the same coordinate system so that you can plot them all together. Otherwise, they won't be plotted in the same area. So we're going to do proj for string to get the projection of that shapefile. And this is a bunch of random text it may seem like, but what you're looking for here is the WGS84. That means that it's in decimal degrees. So that big number with a few decimal points at the end. And we see that outfall and depths have the same coordinate system, which is awesome. That's what we want. But we see that our states are in something called NAD83, which is not so awesome because we want them all to match. And NAD83 is kind of one of those meter projections, which is not something that we really want. So for all of these layers to plot nicely, they all need to be in the same coordinate system. So we're just going to transform the states. So SP transform transforms the projection of states, and we want it to be the same projection as one of the other two layers. So I just chose outfall. You could have chosen the other one as well. But now when we check the projection of states, we see that it's in WGS84, which matches the other two, and so we're good to go. So now we can just quickly plot the data to see how it looks so far. And here we have our US states. This is the coast of California. The white is the ocean. This black line here is the wastewater outfall. And these dashed blue lines are the depths. So I think they're 10-meter depth increments. So like 20 meters, 30 meters in depth. And something to note about plotting shapefiles is that every time you want to plot one on top of each other, you still have to call plot again. It's not lines or points, it's plot. But you just do add equals true to make sure that all of those shapefiles plot on top of each other. Okay, so now we can start loading in our fish data. So we have our acoustic receiver locations, which is a CSV file, and our fish locations. And those are the fine scale GPS positions of that fish because it was heard by a lot of receivers at once. So if we just look at what our receiver locations look like, we have a y-axis and an x. We have longitude and latitude. And then we just have some other metadata with a station name and a receiver ID code. But we see here that we have a negative, so we don't have north and south. We have negatives and positives. And we have decimal degrees. So big number followed by some decimals. Now, if we look at fish locations, we have a dummy variable x. We have times, so year 2017, month 06, day 16. And we have times in UTC time, so global standard time. And it's in military time. So it's not like 2 p.m. or 3 a.m. And then we also have longitude and latitude. And if we look at the differences between our x up here and our longitude here, we see that there aren't any, which is good because we want them to all be plotting on the same decimal system. Cool. So I want to make this plot a little fancier, and I want to plot these fish locations by time. So I want red dots to represent where that fish was at the beginning of when we started tracking it, and then I want blue to show where that fish was towards the end. So to do that, I want to make sure that my date times are in posits format, which is kind of a whole different talk in and of itself. But this just makes it into a timestamp that's friendly for R. So it's already in UTC time, and this format just refers to the format of the date time, which we saw in the previous slide. So year, month, day, hour, minute, seconds. So then we want to take our smart times, so to speak, and change them to numeric time. And this is more of a personal preference because it's easier for me to be able to plot things in sequence if they're just numbers. And this transforms those smart times into basically the number of seconds since 1970, which is kind of a weird numeric system, but it's one that data scientists use a lot. So we'll just go with it, but it'll do what we want. Okay, so I like the color schemes in the fields package, and it has really nice like gradient color scheme that I typically use for a lot of my plots. So I'm gonna load that in, and then I'm gonna set some plot limits. So these I just figured out through trial and error, basically just plugging in a few different variables for your X and Y limits and seeing which one produces a pretty graph. Yeah, so I did the trial and error for you here, but with your own data, you might have to spend a little time figuring out what works. And now we have this final plot code, which I know is a lot to take in, but we will go through it one by one. So for this to be really pretty, I'm gonna first set up an empty plot. So I just chose to plot my receiver locations just to put something in there. I set my X limits and my Y limits. I set my X label and Y label to look pretty. And I did type equals N, and that's just so nothing actually plots, but it just sets up kind of a base plot for me. Next, I always like to do like a nice little blue-gray base map so that it actually looks like we're plotting on the ocean. So this is just adding a rectangle for each of the corners, and it's gonna be slate gray 1, which I think is a nice pretty blue, even though it's called slate gray 1. Next, I want to add my depth contours. So I'm going to plot my depths. I'm going to do slate gray 3, LWD of 2. So that's a thickness of 2, LTY of 2. So that's going to be a dashed line. And then I want to add it to my plot. Next, I want to plot the US states. So we're going to do that in gray. I then want to add my receiver locations. So I'll add points here because it's not a shape file, it's a CSV file. And PCH equals 20 is a nice solid circle. Then I want to add my outfall pipe, which is a shape file. So I'll make it a thicker LWD equals 2, and I'll add it to the plot. Now, if I were to plot it here, you would notice that things like the outfall and the US states and the depth contours actually run into the boundary around the plot. So it's not solid black like what you're used to in R. So I just like to reintroduce a boundary around the plot. So you add another rectangle, but you put an NA color so that it's basically clear with a nice boundary. And then finally, we're gonna add our fish locations. So we have our X, so points for longitude and then latitude, because longitude is our X axis. PCH is 20, so that's that nice solid circle. And then our color is going to be color scale, color.scale. And we're going to take our fish numeric times. So we're going to color code it by our numeric times. ZLim is basically the range of your color values. So we're just going to do the range of the fish numeric times. And then we're going to do the colors as reverse tim.colors 256. So tim.colors is the color scheme that I typically like to use. 256 just says take 256 of this color scheme and choose from that. And then I chose to reverse it because Tim Colors starts as blue and ends in red, but I wanted to start in red and end in blue. Okay, so when we run all that, we should get something that looks like this. So here we have our latitude and longitude. We have our US states, our nice slate gray 1 background, which I think looks like the ocean, our bathymetry lines, our outfall pipe here, and our receiver locations as the black dots. And then we see our fish track. So it starts here. This is where we originally tagged it. And it kind of moves over here and hangs out over here and ends right there. So it kind of looks like a cloud, but that's actually our fish moving around doing whatever it does in about 60 meters depth of water. So about 200 feet of water. So that's pretty cool. And we can actually answer a lot of questions based on these type of data. So for this specific example, we can answer questions like, well, which depths is this fish spending most of its time? And how close is this fish to the actual outfall pipe? Is it actually spending time there? So to answer the first question, we can look at the depth shapefile. So in the depth shapefile, there's a column called field 3, and that actually gives the depth in meters. So if it says -30 in field 3, it means it's at 30 meters depth. So we can load in the library Geosphere, which has a cool function called dis2line, which we'll get into a little later. So I'm just going to grab a random sample of our fish locations, because if you run the entire CSV file or all of the fish locations, it will severely crash your R. So maybe not for today. If you're running this alongside me, I would suggest like a number of 10, because even with 1,000, it took like quite a long time for these analyses to run. So I'd just scale down a little more. So we're going to grab that random sample, and we want to figure out which shapefile attribute is closest to that fish GPS point. So we're going to use dis2line, and we're going to take the longitude and the latitude of our random sample and compare it to depths. And then we're going to convert this to a data frame so that it's easier to kind of add back to our random sample. So this will give us basically the row indices of the depth field, I guess, so to speak, that's closest to that XY coordinate for that fish at that time. So we can now add a depth column to our random sample, which takes the third field, or field 3 of depths, at those index values and adds that to our random sample data set. And if we plot that, we can just do a table of the depths to get kind of a frequency distribution of what those depths look like, and save that as a data frame. And then if you do a table, it automatically gives you columns of freq for frequency and var1 for whatever values that you did the table for. So we can do a bar plot where our frequency, or how many data points fall into that value, are on the y-axis, and the depth is on the x-axis. So here we see that this fish is really selecting for about 70 meters in depth. So it's hanging out in this area between 70 and 80 meters, which is pretty deep. So now we can answer the question, well, how close is this fish to the outfall pipe? And we'll use the same dis2line function to answer this question. So again, we'll take our random sample, longitude and latitude points, and we'll compare it now to the outfall shapefile. And this will give us the distance in meters from that latitude and longitude to the outfall. We'll convert it again to a data frame. And now we'll just take the distance attribute of the outfall distance and add it to our random sample. So now we can see basically for each point in our fish movement data set, how close is it to the outfall pipe? Now, if the fish was using the outfall area a lot, we would see a plot that kind of looks like this. So I just generated some data here to show you what you would expect if that fish was hanging out near the outfall area. You would see a really high frequency of points near 0 up to about 250, because that fish is really hanging out near that outfall. So let's compare it to what we have. And the code to do that is to do, basically I want to round our fish locations into 250 meter groups so that it's easier to plot and visualize. So I'm going to take our outfall distances and floor it, so round it down, but the divided by and multiplied by 250 lets us round to nice groups of 250. And then I'm going to create an expected histogram and an observed histogram. So expected hist is what I generated before with the fake data set. And I'm not going to plot it yet, but I want it to have 12 breaks. And I'm going to save it as expected. And then observed is going to be a histogram of our random sample outfall distances, again with 12 breaks, but again, not plotted. And the reason why I'm not plotting them now is because I want to plot them overlapping each other so we can directly compare what they look like. So if we do that, again in gray, we have our expected points, and in blue, we have what the fish is actually doing. So it doesn't really look like this fish is using the outfall habitat a lot. It's actually spread out a lot more, and it's using a wide variety of different habitats that aren't close to the outfall. So that's pretty good for the fish's health, all things considering. So I know that was a lot to go go through, and I bet you're wondering, oh my gosh, is there an easier way to do this? That was a lot of steps. And there's always an easier way, of course. And ggplot actually has some nice features for mapping. I'm not the biggest ggplot user, but I'm getting more into it. But you can use tidyverse and maps. And so I'll go through that pretty briefly right here. So you can get a map of the world using map data world, and then you can create a ggplot map using the world layer. And a lot of this syntax is just what I found out because I don't really use ggplot for mapping. But similar things is what we did before, where we have our longitudes and our latitudes. We're gonna fill it in with gray, set our X limits and Y limits, and have nice, pretty labels. So if we plot it, you would get something like this, which is a little less fine scale, a little less pretty, but seems a little easier and gets the job done. And now you can still add your fish points and replot it. So you basically have your world plot, which was your base plot that you just created. You can add your points of fish locations with your X being longitude and your Y being latitude. And we're going to color this in just dark orange for now with a transparency value of 0.5. But you could actually plot by date time again. And by doing that, or to do that, you would add something to your AES code that would just be basically color by numeric times, like you did before. And then I just created a different background so that we could have our slate gray one in the background as our nice blue color. And we got rid of those axes lines. So we're gonna get rid of these here. I don't like them very much. So then we get something that looks like this. So it's definitely possible to do it in ggplot if you're more familiar with that and if you're a fan of that. But I found that doing it in just base R, it kind of gives you a little bit more flexibility, I guess. So ggplot actually is also a lot like matplotlib in Python, if any of you also do Python. So that might be easier for you. And in general, in mapping, there's a lot of little steps that you need to go through to make a nice plot. And it can get pretty tricky when you're trying to add your own shapefiles, especially if you want a very fine scale resolution like we wanted for this example. But also to note, leaflet for R is also really cool. I did some leaflet in HTML and JavaScript, and it was awesome. It makes really nice plots. But I don't have much experience in it in R, but it sounds like a cool alternative as well. So a quick recap is mapping in R can be difficult, and geospatial data can answer some very interesting questions once you get the hang of it. And it can also be very rewarding. So with that, thank you so much for listening to my talk. I'd love to take any questions, and feel free to reach out on Twitter. I'm Michelle_Burns, or just, yeah, thanks.
Thank you, Michelle. Looking for any questions on the chat. Oh, Wayne Smith in the chat says, excellent presentation, Michelle.
Oh, thank you. I didn't show my cat if no one has questions.
Aww.
Okay.
What's his name?
Oh, yeah.
Oh, her name is Petals, like flower petals.
Aw, that's adorable. Alicia asks in the chat, was the data from the dog beach in Huntington? Oh.
It was actually not. It's actually pretty close. So the outfall pipe is actually 5 miles offshore. So it's not really close to the dog beach. And I think it's actually, if you map it, it's a bit further south because it's closer to Newport. And I think the dog beach, isn't it like closer to Seal Beach almost? Yeah, so it's a little further south. Yeah.
Cool.
Cool.
Linda asked, what did you mention you used to make this presentation in R?
Oh, so I think it's called IO Slides.
Yeah, that sounds familiar. I think I've used that once before too. Isn't it like an R Markdown form? Oh, I'm sorry to interrupt.
Sort of. Oh, no, you're good. It's very similar to R Markdown. Like the syntax is the same, but instead of doing an R Markdown file, you open an R presentation file. Yeah, I think it's a little more HTML coding than normal R Markdown, but it was fun to try.
Cool. Yeah, it looked very nice, looked very professional.
Oh, thank you. Would I use it again? So I think if I'm doing another like R talk and I need script to like display nicely and show the output, I would definitely use it again. But I do kind of miss being able to actually move things with my mouse in PowerPoint. Because it was like, even to center things, it was all HTML. So that was kind of annoying, but yeah.
And then Ray asks, are there hints of seasonality in fish behavior?
Yes, absolutely. So for the fish that you saw today, the rockfish, the one in the middle, the bright orange one, they actually form offshore spawning aggregations. So in the data set that I showed you, if you were looking at the rockfish, which I think is not what I shared, but the rockfish data showed the fish hanging out by the outfall and then leaving during the springtime when they form those offshore aggregations. But each species is different. So all of the flatfish, like the ones that we mapped today, I couldn't tell if they had seasonal differences because they left so quickly. So the idea was that the project would last a year and I'd be following these fish for a year. All the flatfish left within 2 weeks. So we couldn't really get any seasonal information from those guys. But definitely seasonality in fish behavior is totally a thing.
Cool. Savannah asks, is it possible to know how far the contaminants reach from the outfall? That's a good question.
It's a great question. So yes and no. So the thing with the outfall is that it pushes out the water, right? But it settles really quickly. And when it settles on top of the sand, a lot of different things can change, whether that those contaminants are buried right away or whether they're diffused a little further. And then there's also people in the past, they've done capping projects where they take fresh sand and put it on top of the contaminated sand so that it doesn't come out into the ocean, so to speak. And so, yeah, the wastewater outfall that this project was with, they actually do regular sampling of both the water and the sand surrounding the outfall, up to like a few kilometers away. And what they've seen for their outfall is that it doesn't really get very far from the outfall. So you'd really have to be at the outfall for a really consistent amount of time to see those contaminants.
That's good. Linda asks, would you eat fish caught from Newport piers?
I would not. But that's more of a reflection on Southern California water quality in general. I think most piers are not very good for eating fish.
What more are you trying to do with it? Are you planning to do with that?
Awesome. Yeah, that's a great question. So I finished up my master's about a year ago. So technically I'm done, but I'm actually working on a paper or some more analyses to kind of figure out if I could use this geospatial data to predict how many contaminants are showing up in these fish. So I'm trying to use things like how fast the fish are moving and whether they're turning at fast angles to indicate maybe they're eating things in the sand, and seeing if I can use that to predict whether those fish would have higher or lower contaminant loads. So that's still very much a work in progress, but hopefully I'd be able to figure that out from some of these data.
It's fascinating.
Yeah, sounds
Thanks.
fascinating, and we wish you the best with that.
Thank you.
Okay.
Any other questions for Rochelle? Please feel free to type them in the chat. Oh, Savannah asked, how did you learn R?
That's a great question. I taught myself. I learned it in my undergrad a little bit towards the end, where I was kind of just floundering around running simple statistics. And then when I got to grad school, I had a little bit of time to be able to kind of mess with some real data and just see what I could figure out. So a lot of it was forced by my advisor giving me specific questions and a deadline to answer things. But yeah, so I taught myself, but a lot of what I've learned has come from things like GitHub and yeah, the self-taught seems to be the general trend. Yes. But Google is a great resource.
Totally agree. Yeah.
Yeah, most of my time is spent Googling how to do things instead of actually doing them myself, so.
Yeah, I think that's the case for most people, even if they're like 10 years in. Like none of us are walking Stack Overflow, so we always have to like Google. Yeah. Yeah, Hannah says, I had no idea R could do all the things it can. Yeah, it's pretty impressive, and I've seen its capabilities growing like steadily and almost exponentially over the last few years, especially with all of like the ray shader things. If you've seen like the graphics that R has been able to generate lately, it's incredible, along with like the Shiny applications and other things that R has been able to integrate with in the last few years too.
Yeah, I think they just came out with a new machine learning package too.
Yeah,
like
the
all these
tidy,
fun things.
sorry. Yeah, the tidy models package, right?
Yeah, that one.
Are there public data sets that you would recommend, Michelle?
Oh, sure. So for this type of data for fish movements, I don't think there are any that are publicly available to actually download. But like the shapefile that I got for the US states was free. The bathymetry one was free. And Esri actually has a lot. So Esri is part of ArcGIS and that mapping software, and it's free to get an account with them. And you can download shapefiles directly from them. And they actually have a lot of cool ones.
Cool. Yeah, I've worked with Open NASA and NOAA data for a while now, and I know that they have a lot of like latitude and longitude data sets. I'm not sure if they have like specifically shapefile data sets, but I know that they have a lot of data sets with specifically longitude and latitude attributes. So yeah, that could be fun to work with.
Yeah, as long as you have latitude and longitude, that's all you need.
Any other questions? Okay, there don't appear to be any other questions. So thank you so much, Michelle, for that presentation. It was wonderful. It was very informative. Yeah, thank you so much. Applause.
Thanks for having me. You guys were great.
Okay, so I'm going to share my screen for the final Our Lady's announcement slides. Okay, so here we go. Okay, So we always like to take a few moments to recognize our co-organizers. My name is Alyssa Columbus. I'm the founder and lead co-organizer of this group. I'd also like to recognize Linda Palmer. Hello. Unfortunately, Madeline couldn't be with us tonight. Same with Stacy. But I'd also like to recognize Liliana or Lily for helping us out tonight. So thank you, Linda and Lily. Also, I'd like to open up an opportunity for everyone else to help us with our regular meetups and to help us grow even in 2020. Please feel free to share your ideas for different events, talks, and workshops. If you have anything related to R that you would like to share, we'd love to hear from you. We're always looking for new speakers to fill up slots in upcoming meetings and to share their work and talk about new things that they've done. So yeah, if you'd love to talk about R in any capacity, we'd love to hear from you at the email address on this following slide, and also the email address on our website. It's the same email address, irvine@rladies.org. Also, we could use any volunteers that we could get in any capacity, whether it's related to social media, maintaining the website, finding speakers, other sponsorships, when we get to meeting in person again, helping funding food and beverages, and nice healthy snacks. And yeah, no one person can really support this group and like help keep it going. And I've seen a lot of positive and good done by this group. We've helped people get jobs, learn new skills to advance in their jobs or get new jobs. And yeah, let us know if you'd like to help out and continue driving the good that this organization does. And please feel free to spread the word. This is the last slide. This just illustrates where you can find us online. This is our website, ourladiesirvine.org. You can find out pretty much anything you would like to find out about Our Ladies Irvine on that website. It has links to all of our social media. Yeah, I talked about the blog earlier in this presentation, and it also like showcases all of the events, both past and sometimes future, when I advertise the new meetups. Also, I'd highly recommend you add yourself to the directory of Our Ladies Worldwide if you haven't done so already. It can be found at this link, ourladies.org/directory. Myself and many of my Our Ladies colleagues have been reached out to with opportunities via that directory, so please be sure to add yourself to that directory. Also, you can follow Our Ladies Global on Twitter to get updates from the Global Our Ladies organization, or Our Ladies Irvine as well, for local updates. If you're one of my coworkers or someone else who I invited privately, please join the meetup. Otherwise, yeah, you're already a part of that meetup, so you don't have to worry about that. There's the Our Ladies Global Community Slack, which is really, really cool, where you not only get to meet Our Ladies from locally, you can also meet Our Ladies from like other states and even other countries, and chat together about like solutions to our problems that you're having, different jobs, opportunities that they have, both remote and local to their regions, different resources that they found handy for different things. It's just a lot of great buzz over there. A lot of helpful things going on. Similarly, the SoCal Rug Slack is more localized. It serves all of those purposes, but to SoCal, San Diego, Riverside, LA, Orange County. Yeah, all of the user groups affiliated with this local area can be found on there. And then finally, our GitHub, which I linked to in the chat before. It's github.com/ourladiesirvine. All of our meeting materials are posted here, including all of the materials that were used tonight. So if you wanted to walk through all of the steps that Ashel showed you, or have reference to all of the getting started with our resources, whether for you or for a colleague, they're all there for sharing and reference. And then finally, you can contact us at our email, irvine@ourladies.org, and we always strive to get back to you within 48 hours. So that concludes this meeting. We're about 20 minutes early, but it's all right. If you have any questions, please feel free to put it in the chat. Otherwise, thank you so much for your time this evening. Thank you so much for attending our meeting, and we hope you learned something new, met someone new, and just had an overall good time. So thank you very much. Have a good night.
Thank you, Alyssa and Michelle.
Thank you, Lisa, and everyone.
Thank you.
Thank you. You're awesome. Bye, everyone.